Hi, welcome to Learning Monkey. I am Vikram. In this class, we'll try to understand first come, first serve CPU scheduling algorithm. In short, it is called as FCFS. The detailed explanation about CPU scheduling and the different types of CPU scheduling algorithms has already been explained in our previous video. If you haven't watched that video, please watch that video and come back here. And every video on our channel is going to be part of entire course or a playlist. Our suggestion is to follow the entire course so that you can have better understanding of the concepts. And the link for the playlist is provided in the description below. Now, FCFS, first come first serve scheduling algorithm, simply schedules the jobs according to their arrival time, and it is a non-preemptive scheduling algorithm. So what is this FCFS is? So it is the working mechanism of the FCFS is going to be based upon, it is based upon the arrival time of the process, and it is also a non-preemptive algorithm. Non-preemptive algorithm means, so the processes will be there until it will get terminated, or if any IO instruction occurs in the execution, so which we have already discussed in our previous videos. So now, so what does that mean is, so for example, so let's try to understand this concept in detail. So this part of the definition, so here we are having a pool of processes. In this pool of processes, we have all the processes. For example, here P1, P2, P3, all the processes. So from this pool of processes, we have to assign one of the process onto CPU. So if we are having, we will have a CPU. So to this CPU, we will schedule one process by process. We are going to select one of the process and we are going to schedule it to the CPU. So how that scheduling is done? One of the method is FCFS. One of the method is FCFS scheduling algorithm. So how this scheduling algorithm works is, it is done based upon the arrival time, the time at which the process arrives. So based upon that time, we are going to select the processes from the ready queue and we are going to schedule it to the CPU. So we'll try to understand this in detail by using a separate procedure called Gantt chart. So there is a separate chart called Gantt chart. Using that Gantt chart, we can analyze any scheduling algorithm. So how it works, so what are the different other times that we have, how we can analyze those times, that we can understand by using another chart called Gantt chart, a very simple chart. We'll try to understand using that. So this is how the Gantt chart will look like. So it starts with 0, means this is the point at which the execution of the processes starts. So the CPU will switch on. You can assume in that way. So now using the Gantt chart, we will try to understand how the FCFS will work. So based upon the arrival time, which one is the first process which has arrived onto the ready queue? So it is this process P1 is the first process which is arrived at 0th time. So what is the 0th time means? That is where the processes has came onto the ready queue. So it is relatively the 0th time. So there is no such time called 0th period time, 0th time, but it is relatively, this is the point where the processes has arrived onto the ready queue. Okay, so this is the process P1 has arrived at the 0th time, and it is going to be there on the CPU for two units of time. So 2 units of time, which is the burst time. Burst time means the amount of time taken by the process to complete its execution. So that is the amount of time. It is 2 units of time. Units of time means it may be seconds, it may be milliseconds or microseconds. So, okay, so now 2 units of time is taken. So the process P1 is going to be there on the CPU from 0 to 2. The next process is, it is P2, because it arrived at first unit of time. So this is the process P2 is going to be the next process, and it is going to be there on the CPU from 2 to 2 plus 5, which is the burst time is 5 units of time. So it is going to be there in the process in the CPU for this unit of time. So 7th unit of time. So this is for example, if you assume it as 7th second, so till the 7th second this will be there on the process will be there on the process P2 will be there on the CPU. Okay, so the next process is process P3. Process P3, because the arrival time is the next arrival time is this one, and this one is going to be there. Process P3 is there, and this one will be there for 1 unit of time. And the next one is process P4. Process P4, this is going to be there up to 12th unit of time. And this is process P5, and it has arrived at 5th unit of time and 5th second. If you assume it is in that way, and it is going to be there for 3 units of time. So this process P5 will be there until 15th unit of time. So 15th point of time, 15th second. Okay, so now what we have to do is we have to find the other times also. Means just like completion time, turnaround time, and wait time. Okay, so what is the completion time of all the processes? So the CT stands for completion time. What is the completion time for all the processes? At what point of time the process completed its execution is what we call it as a completion time. So the process P1 has completed at this point of time, it is 2, and the process P2 has completed at 7. Process P3 is at 8, process P4 is at 12, and process P5 is at 15. Okay, so this is what the completion time is, completion time of all the processes. And the next point is turnaround time. So the turnaround time is from the point of arrival, what is the amount of time the process is taken to complete its execution. That amount of time is what we call it as turnaround time. How we can calculate is, it is completion time minus arrival time. So the completion time minus arrival time. For example, if you take the first process, what is the turnaround time of first process is, it is going to be completed second, and it has arrived at 2. So it is going to be there in the CPU, in the entire process of completion, it is going to be there for 2 seconds. Okay, so the turnaround time is completion time minus arrival time. So completion time minus arrival time. So this is going to be 2. And what about the completion turnaround time for this? It is 7 minus 1, which is going to be 6. 6 units of time is going to be the turnaround time. And 8 minus 2 means again it is going to be 6. 12 minus 3 means it is 9. And 15 minus 5, which is 10. So this is what we call it as turnaround time. Okay, now what is the waiting time? What is the waiting time for each and every process? Can you guess? What is the waiting time? So the waiting time is turnaround time minus burst time. So turnaround time means this is the amount of time the process is there, is there in the entire system, so to complete its execution. This is what we call it as turnaround time. Now the waiting time is, it is the turnaround time minus burst time. So burst time is the amount of time taken by the process to complete its execution, so which is 2. So 2 minus 2, which is going to be 0. The waiting time is 0 because the process P1 is the first process that has arrived onto the ready queue. It has never waited for any period of time. Okay, so just by arriving, it has been assigned to the CPU. Isn't it or not? So this is how the things has worked, right? So based upon that, the waiting time for process P1 is 0. And similarly, the waiting time for process P2 is 6 minus 5. It has waited for 1 second. It is turnaround time is 7 minus 1, which is 6. Okay, 2 plus 5. Okay, it is 6 minus 5. It has just waited for 1 unit of time. Okay, next one is 6 minus burst time. 6 minus 1, which is 5. 9 minus 4, which is 5. And this is 10 minus 3, which is 7. So the waiting times are, these are all the waiting times of each and every process. So most of the times what kind of questions that we will get is, it is what is the average turnaround time, what is the average waiting time. So you know how to find the average, means add all this and divide by number of processes. This is, from this we are going to get the average time of turnaround time and average waiting time. Okay, so this is all about first come first serve CPU scheduling algorithm. So this FCFS is having a disadvantage called convoy effect. About the detailed explanation, advantages and disadvantages of FCFS, we will try to understand that in our next video. Hope you got the clarity on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this concept, please post your doubt in the comment section below. And if you feel that this video is helpful to you, please give us a like symbol and please share this video with your friends so that they will also get benefited. Thanks for watching.